Over the years, advances in technology space have not only created new sectors, but have also expanded and developed existing ones. The advances made have seen technology become a part of everyday life, with developments impacting how we work, move, and even how we construct.
It all started where traditionally engineers used to undertake visual condition assessments of road networks, and technology has always been there to support these initiatives of assessing roads primarily at a project level. So we're going back to more than two to three decades.
In order to stay ahead in any industry, one has got to know when to enter and when to exit a space, all the while simultaneously working with right partners to implement the apt technology at the right time. It's one such move which saw the V&A Group acquire the assembly and software development business unit from Australia's ARRB.
It's about bringing this technology to all the industry experts. It's not confined to V&A. And you'll find that within the South African context, we've actually split the two. We have the V&A, which is engineering, and we have ARRB Systems, which is primarily not an engineering entity, but a data collection entity.
South Africa boasts some of the most advanced roads infrastructure on the continent. Traditionally, manual labor has been the tried and tested method of operation when it comes to the construction, rehabilitation and maintenance of the roads network in South Africa. Central to the management of these roads is a process known as the Road Asset Management System.
It's basically using a system in order to manage the maintenance and the routine and basic maintenance of your roads, even going up to the reconstruction and rehabilitation and resealing of your road assets.
Road Asset Management System seeks to ensure that there is due diligence in terms of the investment, the planning cycle, your initiation.
Road asset management then takes cognizance of the fact that the records of what you receive as information after the assessments is then utilized for the purposes of understanding the condition and then creating a prioritization model so that projects can be prioritized in the order of deterioration of roads.
This technology-driven system allows for engineers and those technically involved in the road maintenance value chain to have access to crucial, accurate, real-time data which will allow for informed planning and decision-making.
It influences decision makers because they've actually got information to make decisions on. Without ARRBs, you don't have any information. It's as simple as that. You don't know. So, to put it in a nutshell, decision-making cannot be made if you don't have ARRBs. It's that simple.
Pavement technology has been around for more than 2 decades, and research has proven beyond doubt that pavement technology, if adopted correctly, can definitely assist road authorities in better planning, but more importantly, maintaining road assets effectively. Adopting pavement technology means ruling out subjectivity.
Keys to the success of the Road Asset Management System are the specialized vehicle fleets fitted with cutting-edge technology which allows for the collection and interpretation of data to occur in real time as the customized vehicles move along the stretch of road that is being assessed.
We were the first company to house all of the technology under one roof. So it wasn't just the digital laser profiler and the falling weight deflectometer. We've also got a surface friction tester as well as the ground penetrating radar. We've recently introduced the iPave.
We utilize the iPave, which is the Intelligent Pavement Assessment Vehicle, which uses lasers and cameras. What it does, it takes deflections and also takes automatic crack detections.
We have a number of profilometers, friction testers, gravel road assessment vehicles. The profilometer being one of them, which is a network and project level assessment survey vehicle. It uses the Hawkeye 2000 system, and the vehicle is capable of giving you continual digital imaging, your IRI, which is your International Roughness Index, texture measurements, rutting, depth, as well as geometry of the road.
Once all of this data is collected using the network survey vehicles, the data is then uploaded onto an online web-based platform called the Hawkeye Insight. The Hawkeye Insight allows road authorities to access the information at the click of a button from anywhere in the world.
This technology really helps a lot in terms of it gives precise data and it gives us calculated instrument data that we can rely on, whereas human capacity cannot allocate any rutting, roughness, and deflections.
The use of the technology-driven vehicles in tracking developments on the roads has had a positive spin-off on both the bottom line and the quality of data collected. This has resulted in the more efficient use of resources and thus improved productivity.
As the Free State government, we have been able to invest monies in a proper manner and in accordance with the put-up legislation in terms of DORA.
Initially, we had a challenge as provinces, where we couldn't even identify our network. Now, the introduction of RAMs made our life easier because now it goes with the technology, which is accurate, and then that can also do assessment easier for us.
Traditional methods of data collection, where enumerators were physically deployed along the roads, were found to lack accuracy as there were many variables and factors that could affect the quality and precision of the data collected.
If you look at the original approach that we had physical people doing it. You had then the variances between people, that one person won't do an evaluation exactly the same as the other one. So you had to do extra training, you had to do constant supervision, constant control tests to make sure that the data is as accurate as possible.
The manual aspect of doing road asset management is slow, and it also presents a safety issue for the people doing the road assessments on the road. So the introduction of technology and instrument measurements just assists in getting the work done faster and the accuracy of the data.
Hi, my name is Bongani Ngabinde.
My name is Selwane Lokhodi.
My name is Tebu Khonkon.
My name is Longa Mashia.
My name is Larato Fume.
Apart from human error and safety concerns, there are also environmental factors which could result in data collection being delayed.
We collect the data manually using the tally method, counting the number of cars, and then afterwards we do data capturing. We capture the data into a spreadsheet.
This light, we use it at the morning when the visibility is low, in order my assistants who are doing traffic counts to be able to see when they mark, because at the morning everything is dark.
We can't work on the rain because we are using papers, so it will get wet.
Oh, when it starts raining when we're here, we'll have to find a hiding spot somewhere, and then but we'll stop doing traffic counts for that day.
The safety side of it must be emphasized. When one is having to have a team going down the road, looking at different things, gathering information together, or stopping and starting in vehicles, you can imagine the safety aspect there.
While the advances and positive developments that the new technology promises are real, so too are the concerns of labor, worker unions and organizations. As with most industries, automation is viewed by many as a possible trigger to increased unemployment figures.
Assessing the condition of a road is still something that still needs to be done, and it's still in the manuals and the standards. What we're basically doing is collecting the data first in the form of images and instrument data to assist the individual when they're doing the assessment.
In the circumstances that we are using technology at the moment, the factor is there's still people needed to drive that vehicle. That still people needed to evaluate what the data was recorded, that it is correct. The technology cannot function without a person.
One can cite an example. If there is a reliance in terms of a person who's actually taking data, and he suggests to us that in this particular road, you require patching and resealing. And with the automation, it gives us a different picture where it says it requires total rehabilitation. So if you evaluate the two, you'll then see that the human element in terms of the errors might have reduced the opportunity in terms of creating more job opportunities.
In the old method, because of how they used to collect the data, you wouldn't be accurate to actually know which sections where the problems are, where we need to concentrate on. So you'll find that when they've done a section of 20 Ks and then they find that there were spots of heavy problems, they will recommend a certain activity for the whole section, you know, and then you'll find that actually it was certain spots where maybe there's intersections of heavy traffic and it was only there.
In an era where an understanding of technology is a prerequisite to navigate any sector, South African students and other stakeholders in the civil and built environment space are finding themselves wanting when it comes to understanding and making use of the best practice technologies in data collection, a gap that RAMS Academy can definitely cover.
With the RAMS Academy, it's basically formulated or being introduced to impart knowledge into road authority staff and anyone actually who's interested into knowing how to implement RAMS.
Honestly, it's something fairly new to me. I started doing research about it, so I am aware of it, but I really don't know much about it.
I have a clue of what it entails, and there are a lot of our students that have gone through the same program when they are doing their work integrated learning programs. And not much has been included into our curriculum.
With this academy, that effectively becomes a model that will allow the youngsters that are also the young graduates to come through and be capacitated.
Well, as for RAMS, it was something that I had to do personal research on. It has not yet been covered in our syllabus or in any course that in any module that we're doing so far.
We actually have made tremendous strides and progress in trying to set it up because we're at the infant stage. But we've realized this being a problem in the industry, you want to actually create a sustainable model for any individual that is willing to come on to this aspect of data management, data collection.
The fourth industrial revolution has seen the number of advancements made from a technology aspect in the last few decades far outweigh those of the last centuries combined. So while we might still be in the infant stages of battery and electric-powered vehicles, technologies such as drones have made flying cars landing in our driveways a reality that is much closer than we can imagine.
The fact is that you cannot hide from technology. Technology is available throughout the world, and this has now become the international norm, and it's been practiced over the past 2 decades. So hiding from technology is only setting you backwards.
Technology is the future. It's the future in anything we do, isn't it? So why should roads be different? We have to progress.
For me, it makes sense to apply it, but not only let the technology loose and not look after it. You must control it, you must manage it, you must make sure that you get the right information that you need. With the right inputs, you'll get the right information out.
Technology is evolving, and again it goes back to the question of understanding that as you start to grow as a nation, you also need to start embracing that technology is definitely the future, and obviously people are the ones that make it happen. So it's about them accepting, coming on board to know that we want to work as a collective, because all you're trying to do is to add value.
Technology is the future.
ARRB Systems, realizing global potential.